Good morning, students. Already we have seen the topics such as electric dipole moment, and the electric dipole moment which is acting along the axial as well as the equatorial line. So now what we are going to see is the torque experienced by the dipole in uniform electric field. So consider the dipole. So we are going to consider a dipole, and that dipole we are going to place it in uniform electric field. The first line is consider an electric dipole, and this dipole has a dipole moment P, and that is placed in a uniform electric field. So we are going to place it in a uniform electric field. So it has two charges plus q and minus q separated by a distance of 2a. Next is we have to consider that this charge q plus q as well as the charge minus q will experiences a force. So what is the force that experiences that is given by the charge plus q experiences a force QE, and the charge minus q experiences a force minus QE. And when you see the difference in this is acting along the direction of the field, and this is in the direction opposite to the field. So the charge plus q experiences a force QE along the direction of the field, and the charge minus q experiences a force minus QE in the direction opposite to the field. And when you see the total force, this is QE and this is minus QE. So when you add this becomes 0, and hence the total force is 0. Since the total forces are 0 and that is acting in a different direction, that constitutes a couple. Because of the couple, it experiences with a torque, and this torque makes the dipole to rotate. So that is what is given here. These two forces are at the different points, and this constitutes a couple. Because of the couple, there is a torque, and that torque makes the dipole to rotate. So first we have seen that the dipole is placed in a uniform electric field. Dipole be placed பண்ணிருக்கோம் அவ்வளவுதான். Next is because of the torque, this dipole is rotating, and so first வந்து straight ஆ இருந்த dipole இந்த torqueனால என்ன ஆக ஆரம்பிச்சிச்சு, rotate ஆக ஆரம்பிச்சிருச்சு. Okay, so we have also written with the forces. So this is minus QE and this is plus QE. The distance is 2a, and using this, applying this in the equilateral triangle, consider this to be the angle theta, and when you find the sine in this, sine theta, that is given by the formula for sine theta is opposite by hypotenuse. Opposite here is bn divided by hypotenuse is ab, and so bn is equal to ab into sine theta. When you see the value of ab here, that is 2a, and so we are writing as 2a into sine theta. That you have it as it is. Next is we are going to find what is the formula for torque. The formula for torque is one of the force into the perpendicular distance. One of the force we can take either minus QE or plus QE. Here we are going to take only this plus QE into the perpendicular distance. So this is a perpendicular distance, and that value is given here as 2a sin theta, and so we are writing as QE into 2a into sin theta. We already know the formula for dipole moment, which is given by P is equal to Q into 2a. So instead of this Q into 2a, we are writing as P, and so P E into sin theta. This term, when you are writing in the vector form, we already know that when you are writing sin theta, we will be writing as cross, and when we write cos theta, we will be writing as dot product. Since we are having sin theta here, we are writing as cross, and this terms we are writing in vector. And so the torque is maximum. When it will be maximum? When sin theta is equal to theta is equal to 90 degree. Theta is 90, sin 90 is 1, and so the torque becomes maximum. Next is the when you are placing this electric field which is not uniform. This is a condition. So long we have seen with the condition which is placed in uniform electric field. The last one is when it is not placed in a uniform electric field, the force experienced by plus Q is different from minus Q. So plus Q and minus Q will experience different force, and so in addition to torque, there will be also net force. So in this condition fully, we have considered that the net force will be 0. The last condition we have seen here is the total force is 0, total force is 0 because of the uniform electric field. But when you are considering a non-uniform electric field, the total force will not be 0. And so there will be a net force. So in addition to torque, there will be also net force. So this is about the torque experienced in uniform electric field. Thank you.